All right, so second conic section is going to be the ellipse. So last week we did the circle, and that was very simple. We get a circle by cutting an ellipse parallel to its base. And you can see here we've got the cut, the black line there, and then the cross section that we get is that circle. To get an ellipse, we change the angle of the slice. So you can see as I move the slice, the angle of the slice down, my circle starts to elongate, in this case along the vertical axis. And you can see we actually get quite a bit of elongation. Now if I go too far here, I'll start to get a problem. We haven't got to that yet. But that's where we get an ellipse from. So they're all from this slicing of a cone. And an ellipse just looks like a stretched circle. So we're going to use a lot of the same features of a circle, the center and a radius, but we also run into some problems with that. So we're going to have to modify our approach a little bit. So let's look at that. First, we'll look at the ellipse geometrically. So we'll look at the shape, the oval, and pick out some features there, and then we'll try to convert that to an algebraic view, which would be the equation with x's and y's. So let's start with geometry, looking at the shape and the features that we can see from the shape of an ellipse. And the feature that we first notice is the center. Because it is just a stretched out circle, and as we stretch things either horizontally or vertically, that center doesn't move. So we can start there. Same as a circle, still has the ordered pair HK, and it's still right in the middle. So that's going to be our anchor point, the center of the ellipse. In a circle, all we would need to find from there is the radius. That would give us enough information to write the equation of the circle. Start here, go this distance away in every direction. That's a circle. But in an ellipse, because we are stretching the circle in one direction, we don't have a constant radius anymore. So instead, we break it into two radius values. One horizontal, which we'll use the variable a for, and the other vertical, so a vertical radius, which we will use the letter b for. So altogether, fairly simple. We've got a center, and instead of one radius, it has two radius. Great. Now, there is some extra vocabulary, which is really where conic sections get difficult. Concept-wise, they're easy. You have a center and usually a radius or two radius that you work with, but vocabulary is tough. So we're going to start with the major axis. Major axis is just the longer axis in an ellipse, which could be horizontal if our orientation is horizontal, or could be vertical if our ellipse happens to be longer vertical. And the length of the major axis is just twice its radius, just like in a circle where the diameter is twice the radius. The major axis is a diameter of the ellipse. And at the ends of the major axis, the endpoints where it intersects the circumference of the ellipse, we get a vertex. Vertex here, vertex at the end of the major axis here, and there would also be one here. The other axis then is called the minor axis, which is this one. Uses the variable b and is the smaller of the two axes. So the non-stretched out side. At the endpoints of the minor axis are the co-vertices. The co-vertex here, there's a co-vertex there as well. And you notice the length of the minor axis, because it is a diameter, is just twice the radius in that same direction, horizontal or vertical, depending on the orientation. So this one's not too bad. Hyperbolas and parabolas are where it gets a little bit more confusing. But remember, the major axis is the bigger axis, and the minor axis is the smaller axis. Major, minor, bigger, smaller, fairly simple. These are the features of an ellipse. The center, the major axis, the minor axis, horizontal radius A, vertical radius B. Now let's look at the algebra, the equation. Let's put it together. Like we did with the circle, where we have centers and radius, so let's build something that way. And for that we use the Pythagorean theorem. For an ellipse, we've already got the circle. So we already got x squared plus y squared equals r squared. We're just going to extend that to include the two radius values, which is actually fairly simple. We just use the unit circle and transformation. And what ends up happening is we get this. So if we get rid of these denominators, it looks like a circle with a center at HK and a radius of 1, which is fine. These denominators on the bottom are your horizontal and vertical radius. Now you'll notice A is under X. So whatever variable it's in the same term as, in this case A is with X, that's the variable it affects, horizontal or vertical, on the graph. So I know A is my horizontal radius because it's under the X. And I know B is my vertical radius because it's under the Y. So again, pay attention to the associations in the equation. If it's with the X, it does whatever it is going to do horizontal. H is a horizontal translation. K is a vertical translation because of the variable that it is acting on, X or Y. And notice here we get center at HK, horizontal radius of A. Notice in the equation it is A squared, but I have to take the square root of that to get my actual radius. Vertical radius is B. And then if I wanted to figure out the orientation of this ellipse from the equation, I look at those denominators. If A is bigger than B, well, that tells me that my horizontal radius is larger than my vertical radius, so my ellipse must be a horizontal ellipse. And if B is greater than A, then my vertical radius is the longer or the major axis, and so it must be a vertical ellipse. So now I want to be able to identify these things, these features, from the graph and from the equation. I want to be able to break these apart. And that's our first assignment on Khan Academy. So let's look at some of those as an example. And we will use CUDA. I apologize, I said I was open. But we need conic sections, Now we're looking at an ellipse. So ellipse, graphing, and properties. We don't want to graph it yet, we just want the equations. I don't need that. We want this. So the first thing we're going to do is, given the graph, I want to find the stuff. So given a graph, let's do 2 of these. And I just want to find the center and the major and minor axis. Yep. Actually, hang on. Yeah. Center, there we go. Vertices, the co-vertices, the foci, we'll do the vertices, the co-vertices, the length of the major axis, the length of the minor axis. We don't need the eccentricity. So we'll provide the graph center at the origin, there we go. And let's do 2 of those. Yeah, let's do 4. Okay. Bear with me. So for number 1 and 2, I'm actually going to leave the answer up so you can see the graph, and we're just going to pick it apart. So the first thing, the center, we're going to kind of ignore it. In fact, I'll block it out for right now just so we're not looking. So we know we're looking at the graph, even though I guess you could rewind the video and see it that way. But looking at the graph, the center right there, and so we can see that's 0, -1. So we have a center at 0, -1. To find the major and minor axis, or A and B, I could just count the distance horizontally and vertical. So let's find A first by counting horizontal. So I'd go 1, 2, 3, 4, 5. Check my scale as well, make sure. But A in this case is 5. B, we would go vertical. So from the center, we go 1, 2, 3, 4, 5, 6. So in this case, B is 6, which I know is my vertical axis, and my horizontal axis. You can see, if we look here, center is at 0, -1. Vertices, 0, 5, and 0, -7, going from the center and adding 5 or subtracting 5 from the horizontal value. Co-vertices at 5, -1, -5, -1, excuse me. Vertices are these. That's a vertex. That's a vertex. This is a co-vertex. Vertices are always along the larger axis, which in this case is vertical orientation. Horizontal would be my minor axis. If you look at the length, the major axis is 12 units long. It's this entire diameter, whereas the minor axis is 10 units long. On this second one, the center, you're just looking for the center of the ellipse. So we look here, that one, 1, -1. A would be the horizontal radius. So from the center, I would count out 1, 2, 3, 4, 5. In this case, A is 5 again. B, the vertical axis, 1, 2, 3, 4. 1, 2, 3, 4. And then we could easily find the length of the major axis. Looking at the longer one here, it would be 10. The length of the minor axis, doubling 4, would be 8. The vertices are the endpoints of the horizontal axis, in this case the major axis, so that's a vertex. The co-vertices are the endpoints of the minor axis, in this case vertical. So you do get a little bit of flipping around of vocabulary, but otherwise not too bad. So that's with the graphs. Now, let's look at if we only have the equations, which I'm going to go and change it and just get rid of the graph. So it still wants me to find the center and the major and minor axis. We only need 2 of these. Right. So now we just have these equations. And we want to figure out the center, the vertices, the co-vertices, the length of the major axis, the length of the minor axis, etc. So we look at number 1. X plus 2 squared over 16 plus y minus 4 squared over 169 equals 1. So let's break this down. First thing I'm going to do is find the center. Just HK using inside opposite. So -2, +4. Make sure you're checking the variable because we could switch that around, y minus 4 squared over 169 plus x plus 2 squared, but our center would be the same. Center is -2, 4. So I got that. The vertices and the co-vertices, the length of the major axis, the length of the minor axis, those all are based on A and B, the radius of this. So we're going to look at that next. A, horizontal, A squared is 16, so A is 4. B squared is 169, and so B, the square root of that, is 13. And I know because of that, my orientation, because B is larger than A, is vertical. So my ellipse is longer vertically than it is horizontally, which means these are my vertices, and these are my co-vertices. So from the center, my vertices will be at -2, 4. Because they're vertical, I'm just adding or subtracting b to the y value. So plus or minus 13. My co-vertices, the reason I'm adding or subtracting 13 to the y value is because that's my center and I'm going up 13 or down 13 as the radius along the y-axis. So again, if it's at 4 and that's my radius, then I just use that. The square root of that is my radius. Co-vertices, -2, 4. Everything about conic sections starts at the center. So we start with that -2, 4, the center, and then I add or subtract the radius to the appropriate variable. In this case, 4 is my horizontal radius. So I'm going to add that to the -2, plus or minus 4 there. So I'll just go in, plus or minus the 4 to get that, and that would be my co-vertices. So now we're taking care of those. The length of the major axis. Well, that's the bigger axis, so it must be twice this radius, so 26. And the length of the minor axis would be 8. We'll do the same thing on this one, a little bit quicker though. The center is at what value? 8,2. Good. Inside opposite, 8,2. My horizontal radius, if I have this 121 under x, I know the square root of that is 11. So my horizontal radius is 11. My vertical radius is 225. Square root of 225 is 15. So my vertical radius is 15, which tells me the orientation of this ellipse is vertical again. So we have a vertically oriented ellipse. Our vertices will be at 8, 2, plus or minus my vertical radius, 15. My co-vertices will be at 8, plus or minus 11, and 2. And that's based on the orientation. If this particular ellipse had been oriented horizontally, then my vertices would be the endpoints of my horizontal axis. So these would become the vertices and these would be the co-vertices. But since my vertical radius is the larger radius, my vertices are at the endpoints of the vertical axis. And so that's why I used the 8, and 2, plus or minus 15 for those. The major axis has a length of 30. The minor axis, 30 units. The minor axis has a length of 22. Now, on Khan Academy, I have opened up some exercises and videos that also go over ellipses. Again, the exercises are your homework. That's what I'm going to put into Skyward. The videos are there to help you out. So if you are struggling with something, watch the video. If you think you've got it, do the exercises. Once they're done, you're good to go. All I'm looking for you to have done really right now are the first 2 exercises, I believe, dealing with the features of an ellipse from its graph and from its equation. So it's those first 2 exercises. And I'll post something on the classroom with this to tell you which ones to do. Wednesday, I'll post another video. It's really about every other day. We'll go through this, get a new video on the next part of ellipses. And then Friday we'll finish up. And I think I pushed this to next Friday because again, we only really have conic sections and a few other topics that we need to go over. We'll have all of May to do those. So we're in the final stretch. So if you're stressing out, don't stress out. If you need assistance, email me. If you're having trouble accessing anything, email me. The deadlines that are on Khan Academy are not set in stone. If you need me to open something else back up, that's fine. Email me and I will open that up. They're just there to give you a deadline so that we're not trying to get everything done really the last day of April, the last day of school. So there's soft deadlines. Try to make sure you're working on it. Not too long. I'm thinking maybe 30 minutes to an hour every other day should get you through, hopefully. That's my goal. I don't want to stress you out. I know this is a big change. We got a lot of other stuff going on. So pay attention, make sure you're studying. There will be a test on this at some point. I know last week I said Friday, but I don't think that's realistic. So next Friday, I think that's the 17th, is what I'm going to aim for circles and ellipses. And then at the end of April, we will probably have a test on parabolas and hyperbolas. And then into May, we'll get into those. But it's really just limits and continuity and sigma notation, prepping some of you for calculus. All right, guys. Hope you enjoyed. Have a great day. Stay safe. And get those exercises on Khan Academy done. Later.